It is easy to get started with a Snowflake, and that's why many businesses often adopt Snowflake at first, but later question its cost efficiency and seek best practices to minimize expenses and avoid wastage of storage and compute resources. Snowflake has a reputation of getting expensive really fast, but if you know how to do right things and follow best practices, you can surely control the cost and stop credit leakage. Snowflake follows a pay-as-you-go pricing model. So, whatever services you utilize as a Snowflake feature for your ETL or ELT workload, such as stream and task, pipe objects, materialized views, data loading using copy command, dynamic data masking, or data replication, they all consume either compute resources or storage or both of them, and you will be charged accordingly. However, how can you make sure that the feature used for your workload is making most efficient use of storage and compute resources? If you and your team are unaware of right things, it could result in substantial credit expenditure, meaning significant cost. In this video tutorial, we will cover frequently used Snowflake objects and features, how they are built in terms of credit usage, and important tips to control the cost. This way, you can evaluate your Snowflake setup, identify any credit leakage, take corrective actions, and save a lot of money. We are familiar with Snowflake credits, but it is important to know the type of Snowflake credits and how they translate into dollar values. Credit is a unit of measure in Snowflake, and it is divided into two broad categories: compute credit and storage credit. If we go further down, the compute cost comes from compute services that includes warehouse compute, automatic clustering, materialized views, search optimization, cross-cloud replication, and so on. The next category of compute service is cloud service, and if you pay attention to this list of activities being performed by cloud services are authentication, infrastructure management, metadata management, query parsing and optimization, access control, and so on. For smaller Snowflake instances, the cloud service cost is very minimal. But if you manage large Snowflake instance, all those SQL statement and UI navigation that don't need any virtual warehouse are also part of cloud service cost, and the cloud service cost could be noticeable. Next, we have storage cost. All the data that we load into Snowflake are stored inside tables, and tables are created in the context of database and schema. Tables holding the data are called active storage. There are other features that also need storage. For example, time travel, fail-safe, clone retention. Internal named stages, user stages, and table stages can also cost you as it holds data files. When we say we have consumed 10 credits or 20 credits in Snowflake, it is not always $10 or $20. The credit pricing depends on three factors: the Snowflake edition, the cloud provider, and the region. Higher the Snowflake edition, more the dollar value. The Snowflake comes in 4 different editions: Standard, Enterprise, Business Critical, and Virtual Private Snowflake, which is also called VPS. A Snowflake instance can be hosted on 3 different cloud providers: AWS, Azure, and Google Cloud. And we can choose different region to host our Snowflake instance. So I am in Snowflake pricing screen, and if I select AWS as my cloud provider and the region is US East, Standard Edition cost me around $2 per credit, Enterprise Edition cost me $3 per credit, Business Critical cost me $4 per credit. If I change the region from US East to Europe Central, the Standard Edition cost changed to $2.7 per credit, Enterprise changes to $4 per credit, and Business Critical cost me $5.4 per credit. The storage cost per terabyte also changes as you change your cloud provider and region. As a Snowflake platform owner or a consumer of a Snowflake services, it is very important to understand how this credit can be related to your dollar value, because at the end of the day, the dollar value matter most. So let's start with most commonly used object called tables and explore its cost implication. In Snowflake, we can create 3 types of tables: permanent tables, transient tables, and temporary table. If you are interested in go deeper into Snowflake tables and their features, you can explore the playlist or watch this hands-on video tutorial that covers everything in detail. Permanent tables leads to higher storage cost if not designed correctly, as it supports two powerful features called time travel up to 90 days and failsafe for 7 days. The time travel parameter can be changed from 0 days to 90 days, but failsafe feature is non-configurable. So no matter what you do, it will always have 7 days as a period. For transient and temporary tables, the maximum time travel duration is 1 day, and these tables don't have failsafe feature. So let's say you create a permanent table. On day 1, you inserted 10 GB worth of dataset. Next day, you modify many records, and for simplicity, let's assume that the modification is equivalent to 5 GB of changes. You perform similar operation on day 3, and on day 10, for some reason, you decided to drop the table. And if the table has 90 days of time travel parameter, and since it is a permanent table, its failsafe period is 7 days. Now, you may think that it will charge only for 10 days, but no, since it is a permanent table and the timetable duration configured for this table equals to 90 days, the total storage cost will be charged to your account for 97 days. So when you create one or a many permanent table, think twice and classify a table as a permanent table only if it is needed. Otherwise, you will end up wasting a lot of storage credit cost in your account. If you are not sure whether you need a recovery or if these tables are only for development activities, make sure they are created as a transient table. In Snowflake, if you have not put a classifier as a temporary or a transient, by default, all tables are permanent tables, and generally that is what the mistake we all do. So bring awareness in your Snowflake data platform team. And if you are an administrator or a data platform owner, continue to monitor the table level storage or create custom monitoring using Snowsight. Let's talk about internal named stages, table stages, and user stages. There are 4 types of stages in Snowflake. User and table stages are called unnamed stages. We can also create internal named stages. External named stages don't have any storage cost, but all other stages have storage cost. You can store any kind of file inside these named and unnamed stages. Snowflake has no restriction of size and file format. So, if a user is storing a lot of data file inside the user stage or a table stage, there is no way it can be controlled. Table stages can still be controlled using RBAC, but user stages cannot be controlled using any RBAC policy. Hence, any user having access to your Snowflake can use user stage as a storage location. So if you have a user base who are not using Snowflake, you delete their account, and when they want to work in Snowflake environment, you can onboard them again. For named external stages, you will not have any storage cost. But if you offload a lot of data files to S3 bucket and run some list SQL command where external stage has a lot of files or deep partition, then this list command will run longer and will burn lot of credit. Even this data offloading will trigger a file transfer egress cost, and that will come under your data transfer cost. So bring awareness in your Snowflake data platform team, and if you are an administrator, continue to monitor the stage storage report and its overall trend. If you look into this graph, it says that 20 GB of data is being stored in the stage location and there is no downtrend or uptrend. It means that your Snowflake account will be charged for 20 GB of data every day, and if this data is not meaningful or useful, then probably you can get rid of this data or you can transfer this data into compressed format inside Snowflake tables. From this report, it is hard to understand the storage consumption under user stages and table stages. But if you can create additional dashboard using Snowsight to check if anybody in this platform is storing a lot of data in the storage location. There are different approaches that can be followed to detect and identify a user who has added large file into unnamed user stage, and that we will cover in a separate video. Next, let's talk about zero copy clone, as this is also related to storage credit cost. Zero copy clone is a very powerful feature provided by Snowflake, and it can save a lot of cost. A clone operation can be done on database level or schema level or at table level. Zero copy clone does not copy the underlying data, and the newly created object, so-called cloned object, refers the internal partition without running any copy operation under the hood. Let's understand with a simple example. If you look into this timeline, after creating a clone table so-called T2 from the source table so-called T1, at the time of creation, both this table refers to the same internal micropartition. Once you create this clone table, you may perform independent DML operation as shown in this diagram. On day 1, a DML operation is executed on table T1, and on day 2, another DML operation performed on the table T2. And these operation creates new micropartition without changing the old micropartition. And if you continue to perform such DML operation on the source table as well as on the clone table, it will continue to do so. And since the clone table refers the micropartition of the source table, Snowflake has to hold micropartition file for reference. And this all depends the kind of a DML operation you perform on source and clone table. So don't assume that the zero copy clone will have no cost, and based on the DML operation, it may incur storage cost. And again, if you are an account administrator and query the table storage metrics view under account usage schema and check retained for clone field and validate it. We have spoken about time travel feature, but I would like to make some additional point about this feature. First, let's talk about time travel duration for different Snowflake edition. In standard edition, the supported time travel duration is 0 to 1 day. In enterprise and above, the supported time travel duration is 0 to 90 days. Time travel parameter can be set at account level, database level, schema level, and table level. If it is not set, then the value is inherited from the parent object. So, table will inherit from schema will inherit from database, and database will inherit from the account. The default time travel duration at account level is 1 day, be it standard edition or enterprise or higher. And if not changed or altered, all the objects that support time travel gets the default value, which is 1. And we have understood if a permanent table has 90 days time travel duration, and if table has a high churn rate, means lot of DML operations are performed, and even if the table is dropped after 10 days from the day of creation, it will still incur lot of storage cost until the end of time travel period plus fail-safe period. To ensure that your Snowflake environment is set up properly, you can review the account level time travel duration, and all the lower environments, which are called non-production environment, that is used for development activities or a learning purpose, should have either 0 or 1 day time travel duration setting. And make sure that you regularly monitor the time travel value for tables created by different team members and users in your Snowflake environment. If a user has got a create table grant privileges, which generally you have to give it to your user, that user can create any kind of table in your Snowflake environment, and Snowflake does not have any specific restriction that forces the user to create only transient table or a temporary table and not to create a permanent table. So this is a big problem, and this can be solved only by bringing awareness and following the best practices in your data team. There is one alternative to ensure that people do not create a permanent table even by mistake. So if you create a transient database for your development activities or learning activities, by doing so, the database will not have any fail-safe period, and all the schema under this database will not have fail-safe period, and all the table under this all schema will also not have any fail-safe period. This way, your Snowflake account will not incur any fail-safe cost for those tables which are created for development and learning purpose, and its time travel duration will always be set to 0 or max 1 day. So make sure that you follow this guideline and also educate your team members. If you have a large team, you would see how much cost saving this brings to your Snowflake account by following this guideline. Let's talk about data loading and copy activity, one of the most common activity every Snowflake project will have. And our discussion will be incomplete without considering the copy activity feature and its cost implication. To load data into Snowflake from stage location to Snowflake tables, we need to run a copy command. Copy command can be executed on an internal stage that includes user stage, table stage, or named internal stages. Or it can also bring data from external stages like S3, Azure Blob, and Google Cloud Bucket. When you run a copy command from external stages, it needs a file format object that can parse the individual field element and then insert it into Snowflake tables. In Snowflake, there is no ingress cost, but yes, if you are offloading data from Snowflake to other cloud storage or even in your local machine, you incur egress cost. And the copy command can also be executed to offload the data. So to run a copy command, you need a virtual warehouse, and as long as your virtual warehouse is active to support the copy command, it consumes credit. So let's understand the copy command cost implication with this illustration. If you are using copy command with an extra small virtual warehouse, and if this warehouse is up and active for 1 hour, copying different dataset, either using a stored procedure mechanism, wrapping the copy command, or using a scheduled task which calls this stored procedure, which eventually calls the copy command, it will consume 1 credit for 1 hour. And if the copy command completes its execution within 1 minute, it will cost you 0.017 credit. And if the copy command gets completed in 5 minutes, then it will consume 0.083 credit. And if you see the dollar value for different Snowflake edition for extra small virtual warehouse, 1 credit will translate to $2 for standard edition, $3 for enterprise edition, and $4 for business critical edition. So the same copy command will have the different dollar values based on your Snowflake edition. And I am assuming that your Snowflake instance is running on AWS US East region based on this pricing sheet. So this is very clear and evident that the same copy command will have a different dollar value based on your Snowflake edition. In the real life, the credit amount will be marginally higher than what we have depicted here. Because after finishing the copy command, the warehouse will be inactive for 60 seconds, and after 60 seconds of inactivity, Snowflake will suspend the warehouse, and for that duration, your account will still be charged. So if you run the same copy workload to a small size virtual warehouse and warehouse is active for 1 hour, then it will consume 2 credit, and likewise for medium warehouse, it will consume 4 credits. So if you are copying a lot of data or entities from your stage location, make sure that your copy workload is designed appropriately. If you have control over file formats and compression, prefer to use CSV file format with gzip compression, as this is most cost efficient configuration for your copy command in Snowflake. Avoid applying any transformation during copy command. Avoid placing large file in your stage location. Use smaller files and use partition as much as possible in your stage location. Don't use patterns and regular expression for your file path, as listing operation is an expensive operation in Snowflake. For delta load, use Snowpipe, as Snowpipe is a serverless component and does not need a user managed virtual warehouse. Review all your copy command where you have used the parameter force equals to true. For large file, this could be a duplicate operation and it may cost a lot of credit on your subsequent rerun. Let's talk about virtual warehouse and understand what best practices can be defined so it leads to cost saving in your Snowflake environment. Virtual warehouses are account level objects that we use to run our queries and transform workload, and there are some important points and best practices. If followed, we can see a lot of cost saving. When we create a virtual warehouse in Snowflake, Snowflake gives a lot of options and we have to review them and change them if needed before we create one. While creating a new virtual warehouse, make sure the auto suspend and auto resume parameters are set to true. Auto suspend is an important parameter, and if this parameter is set to false, it may happen that your warehouse is continuously running without any workload activity and it will burn a lot of credit. The default value in Snowsight Web UI for auto suspend is set to 300. Don't forget to change it to 60 seconds, means 1 minute. Also, set the initial suspended parameter to true, else Snowflake will immediately start the virtual warehouse right after its creation via web UI, and that is not required unless you are planning to run a workload. This option is currently not visible in your Snowsite web UI warehouse creation screen. If a user has privilege to create a virtual warehouse, he or she can create any kind of virtual warehouse. So be careful assigning this privilege to your user. Also, make sure your user should not have the modify privileges. By giving that privilege, the user can also resize the warehouse. That may cost a lot of credit if it is running a small workload in a larger virtual warehouse. So for example, Snowpark optimized virtual warehouse start with medium size, and if a smaller workload is running in Snowpark optimized warehouse, this will not be the right design approach. Likewise, if you are running a multi-cluster virtual warehouse with incorrect setting, this will leak a lot of credit without any real purpose. When a new Snowflake instance is created, a virtual warehouse named compute_wh is automatically made available in your Snowflake instance. And we all have a habit of using this warehouse for all our learning and development purpose. So make sure that this virtual warehouse is deleted in your enterprise edition or its usage privilege is removed, and create meaningful warehouses for different kind of workload to have a better monitoring capability in your Snowflake environment. So my overall recommendation for virtual warehouses: avoid creating virtual warehouse from your web UI and do it either using automation or by running SQL commands. Readjust, like modify and create privileges on your warehouse in your Snowflake environment so you can avoid human errors. While creating a virtual warehouse manually or via automation, make sure these parameters are reviewed thoroughly. Review Snowpark optimized or multi-cluster virtual warehouses before they are being created. Otherwise, it may burn a lot of credit without your knowledge. Also, make sure that you review the usage on a regular basis and understand the trend, and accordingly take action if your virtual warehouses is active without any workload or without running any queries. We are all aware that task objects assist in running single queries, calling stored procedures, or executing procedural logic through Snowflake scripting. The task can be scheduled and they require compute resources to carry out these actions. Let's explore how to use them efficiently. Two kinds of compute resources can be attached with a task: managed warehouses or serverless warehouses. For very small workload that takes less than a minute, it is better to use serverless warehouse. Let's assume you have a task that runs a query and that query takes roughly 10 seconds to complete. And if you are using a managed virtual warehouse to run this task, the virtual warehouse will still be active for 60 seconds even after completing the task within 10 seconds. And it will burn credit worth 60 seconds even though the query got completed in 10 seconds. So if I take this situation and if you run this task every hour for 24 hours a day for 30 days in a month, the total credit consumption will be 2 credits as shown here. But you end up paying 12 credits because your warehouse minimum billing is for 60 seconds. So look into your workload and choose managed or serverless warehouse accordingly. When it comes to running a task, there are two different ways to run a task. You can set the frequency using cron style or using scheduled parameter. Make sure that you review the frequency. If you set the frequency for a minute, your virtual warehouse or a compute resources will run throughout the day and you will burn a lot of credits. The challenge here that once you allow a user to create a task and resume privileges, you don't have any additional power to control the frequency of execution. And if multiple users are running tasks throughout the day using managed compute or a serverless compute, it can burn a lot of credit. There are another parameter provided by task to suspend it if it fails during the execution. This approach should be followed when you are running a very large workload, and if it continues to fail without serving its core purpose, it should get suspended automatically. So it should not incur any cost for subsequent execution. So if you are an administrator of your Snowflake account or having necessary privilege, continue to monitor the cloud service spend, specifically when you are running a lot of tasks using your serverless compute. We have gone over 7 crucial Snowflake objects and features that are used virtually in every Snowflake data project. When these features and objects are thoughtfully integrated into your data project, especially during the construction of data ingestion and data pipelines, following best practices discussed in this tutorial, you will notice a significant reduction in your credit consumption. Snowflake offers numerous other objects and features where we can discuss the best practices and create cost-saving guidelines. However, I will cover them in future videos if you are interested to know more about them. You can share your interest in the comment section. If you have a compelling story or strategy related to Snowflake lesson learned and cost saving, don't hesitate to join my Facebook group and share it. Many like-minded data professionals are part of this community. Alternatively, you can also reach out through my Instagram account. If you have learned something from this video, please consider liking and sharing it, and by doing so, YouTube will serve more relevant content from my channel to help you in your Snowflake journey. So, happy learning and keep growing.